This lesson will go over simplifying rational expressions. The learning goal is to simplify rational expressions, and the success criteria is you can simplify a rational expression by factoring and dividing out common factors. So a rational number is any number that can be expressed as a fraction. A rational expression is a fraction of two polynomials. So for example, 2x minus 1 over 3x, that is a rational expression. It is important when working with rational expressions to include any restrictions. These are values that cause the denominator to equal 0. So for example, we want to state the restrictions on x minus 2 over 4x plus 3. Restrictions occur, or when we find restrictions, they always occur when your denominator equals 0. So what you do is just take your denominator, in this case 4x plus 3, you set it equal to 0 and you solve for x. So this is going to give us 4x equals to negative 3 divided by 4, and that means that x cannot equal negative 3 over 4. If it does equal negative 3 over 4, our denominator will be a 0, which is not mathematically allowed. Now, when you simplify a rational expression, there are several steps which you need to take. First, factor if possible. Remember to only factor if you have multiple terms in numerator and or denominator. For instance, you wouldn't factor 4x squared, but you would factor 4x squared minus 1. You also want to divide out any common factors. So remember that factors must be exactly the same. So here we can divide 3 out of 3x over 3. We can cancel these both out, but we can't do it in x plus 3 over 3. Now the reason being is that x plus 3 over 3 here, when you're dividing something out, when you're canceling, that means that that particular value, number, variable that you're canceling, dividing out, exists in every single term of the numerator. So here, this x does not have a 3. This 3 is a 3, so you can cancel 3 out there, but this x does not have a 3. If you look at this another way, remember that this denominator, that's actually dividing every single term. So it's actually x over 3 plus 3 over 3. This is what this expression really is. So yeah, you can cancel it now on the right here because we have 3 over 3, but you still can't do it on the left here because that x does not have a coefficient of 3, so you cannot cancel this 3 out. You can't do that because both the terms in the numerator do not share that factor. And then you need to state the restrictions. So again, these are values that cause your denominator to be 0. You must include all values, even the ones that are canceled out. So for example, we're going to state restrictions on x times x minus 1 over x minus 1 times x plus 1. So here, we have a numerator of x and x minus 1 and denominator of x minus 1 times x plus 1. There's no simplification we can do here. We could expand this, but we already noticing that everything seems to have already been simplified. We can, however, notice that x minus 1 is on the numerator and denominator. There's only one term on the top, one term on the bottom, so we can cancel out x minus 1 from both numerator and denominator. That would leave us with x over x plus 1. We can't cross out these x's because on denominator, your term is technically x plus 1. We can't cancel it out as on the top we only have an x. We don't have that plus 1 up there as well. So the restrictions is whatever was on your denominator and whatever was canceled out. So we canceled out x minus 1, so we have to set that equal to 0. And we also have a denominator x plus 1. So both of these, when solved, is going to give you that x cannot equal positive or negative 1. So putting it all together, you could simplify and set restrictions on any rational expression. Pay close attention to the steps. The 3 steps above are common errors when working with these problems. So either you factor out incorrectly, you forget some of the restrictions, or there's some mistakes in the simplification step. So here we're going to simplify and state restrictions on the following. So these two examples here. On our question A here, there's no additional subtraction here. We just have a single term on numerator and denominator. So we can look for common factors that we can cancel. we have 7 on the numerator, 21 on the denominator. We can cancel out 7 from both of these. So taking 7 out of 7 leaves us 1, and canceling 7 from 21 leaves us with 3. So that's 1 over 3. Then we have the a squared a to the power of 4. Remember, with exponents, if we're dividing a to the power of 2 over a to the power of 4, these subtract, so it's a to the power of 2 minus 4. That gives us a to the power of negative 2. And then we have b to the power of 3 over b. So 3 minus 1 is 2, so it's b squared. We can then take the negative exponent. Remember, negative exponents need to be placed on the denominator. So that is 1b squared, which is b squared, over 3a squared. So that's our fully simplified expression. And our restrictions are that a cannot equal 0 and b cannot equal 0. We know they're both instantly not equal 0 because there is nothing being added. Subtracted here is just a and b on your denominator, so we can set them both to not equal 0. On our second example here, we have 5x plus 15 over x squared minus 9. We can do some factoring here. So on our numerator, we have 5x plus 15. We have a common factor of 5. We can factor out 5 there, so that's x plus 3. And then on the denominator, we have x squared minus 9, a difference of squares. So we need two values that multiply to x, two values multiplied to 3. So that's x minus 3, x plus 3. And now we can see that we have a shared factor on the top and bottom. We have x plus 3. We can cancel those out. And that gives us 5 over x minus 3. And our restrictions here are that we had x plus 3 that we cancel out, so we have to set that equal to 0, and we had x minus 3 on the denominator still, that we can set that equal to 0. So here, this gives us that x cannot equal plus or minus 3. So as you work with rational expressions, just pay close attention to these steps. Factor, simplify, make sure you're canceling terms as only when every term does on the numerator does have that that value, and that you are always stating restrictions for your denominator and anything that you've canceled out.